Thank you. So with the who am I mostly out of the way already, I just want to preface that while I do have the pleasure to work on this topic also at my work, this talk, or what I'm going to talk about, is actually mostly about my passion project and what I do in my spare time. So like it is related to what I learned there, but it's going beyond that. And let's be honest, you're not here for me. So instead, let me introduce you to a fictional character called Molly. Molly is a SecOps engineer. That was not intentional. A SecOps engineer working or starting now at KUK Containers. It's a small company with around 300 employees and around 100 engineers. And it's about time they have a dedicated security person, and Molly is in the lucky position to fill that spot. And her task, like she was previously not working for any or focusing on security, but now she's responsible for security the product. So this begs the question, what does secure actually mean? She's like no total stranger to security, so she's aware of the defense in depth model, or sometimes also lovingly called the Swiss cheese model. And the concept is that there is no single security tool that can cover all of your bases. So instead, you have to layer multiple of the security tools and hope the combination of those keeps you secure. And thankfully, there is the CNCF landscape with plenty of tools available. And she goes with the most commonly known ones. She goes with Trivy for vulnerability management of the workloads and misconfiguration scanning and compliance. For admission control, so securing what gets into your cluster, she sticks with the Kubernetes native capabilities. And for runtime security, she goes with Falco. Now, everything is working greatly. She deploys everything and the results start coming in. Lots of them, like she's the first security person, lots of high risk finding or critical risk findings. And it's very overwhelming that all the tools for all the workloads, like they seem to be screaming at her, which is very overwhelming for her and really challenging. And most importantly, she's still not sure if this actually makes the environment secure, if she's fixing all those findings one by one, top down. So not very satisfied with the current status. She goes out and does some more research and finds this quote by John Lambert: "Defenders think in lists, attackers think in graphs. As long as this is true, attackers win." And this quote is already 10 years ago, but it's now as true as ever. And this really resonates with Molly because it resonates with her, like the lists, they're like a dead end. And she also starts to question how can she reframe what secure actually means. And the best idea is to flip it on its head and say the insecure part, or secure is the absence of insecure is the absence of security. So it means whatever an attacker can use and exploit, that's actually the lack of what's missing or what's supposed to be there. And this brings her in the mode to change her mindset a little bit into more the trying to understand what attackers do. And a very good source for inspiration for that is threat intelligence. So there's plenty of evidence out there what attackers do, how they behave, and there are companies like Wiz collecting all these findings in the cloud threat landscape or several different blog posts by various vendors. And it's very informational, but she doesn't have time to stay on top of all the news all the time. So thankfully, MITRE, the organization, continuously works on the so-called attack framework, where they try to catalog all the malicious tradecraft out there and place them in so-called TTPs, which stands for tactic, techniques, and procedures. So the idea is one attack or a campaign usually consists of multiple phases, which they call tactics, which is at the top of this framework. And usually you have an initial access stage, then some things in the middle, and finally some sort of impact, the ultimate goal, what an attacker tries to achieve. Then every tactic consists of one or multiple techniques. So here, for example, the classic, the exploit public-facing application, everyone knows that. And if you have ever looked at any sort of security tooling, it's not very uncommon that those tools actually refer to exactly those techniques. For example, either the tactic, defense evasion, or this ominous number, which points exactly to that technique. And every technique actually consists of one or multiple procedures, which is actually how this is implemented or how this manifests in real environment. So now with this framework, what experts usually do is they start chaining them together, depending on the context and environment, and can try to build or construct more graph-like scenarios. And this is already very helpful. So Molly goes ahead and tries this exercise in her own environment. This is in their company. They have like this principle that developers are the king of their own namespaces. So the company or the platform engineers try to secure it, and the engineers can do what they need to do within the namespace. And in this scenario, the orchestrator workload is a very important one, and it happens to have a security finding flagged by a trivia. And now the game goes, Molly assumes she's a hacker. She assumes she can compromise this vulnerability in some sort of way. It doesn't have to be exposed externally. There are plenty of other initial access vectors, but she's able to compromise it. And then from there, once she's within the pod, she then can actually impersonate the service account token, which happens to have the credentials to manage pods. And with those new gain capabilities, she can actually start creating new workloads. For example, a new pod which mines crypto. So this is still by far the most common attack scenario in Kubernetes environments. Not that dangerous, mostly annoying and expensive. But in this case, it could be way worse if they, for example, configure the pod to allow easy escape to the host machine, because then they are outside of the net namespace and then can escalate their campaign to other teams and the full cluster. And this is also where it helps to have other security findings, like Trivy supports the misconfigurations and compliance checks as well. And for example, one of those checks is that you should have at least enforce the pod security standard baseline for your namespaces. And if you were to do that, then this attack vector would not be possible, at least. So with this, she's already able to combine different kind of findings. And to summarize, so what we did is we modeled this in the fictional environment, or ideally, if you already have a threat model, you can that already and build on top of that. And the idea is you model out all of those attack paths, and this also assumes the full visibility of your environment. So this is usually only possible by defenders because they know everything and attackers usually don't. So there's a strong advantage there. And this is a very good tool to contextualize the findings, like vulnerabilities, misconfigurations, and the business criticality of certain workloads. And for the more sophisticated or professional security experts out there, it also unlocks more advanced types of analysis. Doing this manually is very tedious. So Molly could write tools, could write scripts and create her own tools, but thankfully there are already a few open source tools available. Sadly, I only know of 2 which focus specifically on Kubernetes, but for other environments, there are way more attack path analysis tools. So these 2, CubeHound and IceCube, both support 25 TTPs, but those TTPs are like different sets. So depending on your environment, depending on your use case, your mileage may vary depending on which tool you pick. Regardless of the tool, what they give you is some sort of attack graph, which you then can query yourself. So it doesn't provide you with the final answer, but you have to query it and use it alongside your own analysis. Now, with this exercise, she was already able to quickly filter out a lot of the noise of what Trivia provides and know what is really important and where to focus her time on, because after all, she's just one SecOps engineer supporting hundreds of engineers. But that was just trivial. She still has other security tools as well. What about the admission controller and Falco? And most importantly, what did she miss at all? Like, that's actually what matters with regards to security. So she understands that the map is not a territory and attack path analysis is purely just a map of things. Now she has to get real and try to get her hands dirty. So she does some more research, and that brings us to adversary emulation, meaning perform actual attacks on real environments. Like, it doesn't have to be production, but it must be real environments. And this is the ideal counterpart to really evaluate all the existing security tools at your disposal. And I differentiate between the tools along the axis of realism. To the very left, you have atomic tests, and to the very right, you have real human doing red teaming assessments. And then somewhere in the middle, you have different flavors of that. So for atomic emulation, what you usually do is you pick one single TTP you want to verify. For example, she just deployed Falco in her environment, and she wants to make sure something gets picked up. So she detonates a TTP she hopes will be found, and sees what happens. So depending on the tool, some infrastructure may be provisioned along the way, but after the detonation, then automatic cleanup happens as well. And she then does the correlation between the security detection tool and whatever she tried to find or detonate. And there are also tools available for that. So Atomic Red Team is by far the best tool when it comes to workload-based kind of TTPs. So they have plenty of TTPs, both for Linux and Windows environments. And if you want to execute TTPs more around cloud environments and Kubernetes specifically, you can use Stratos Red Team, but they have a very heavy focus on AWS. And one tool I mentioned here, but I still want to fail to mention here, but I still want to mention is Leonidas. And they are both very similar, but in the sense that you execute it, point it to a Kubernetes cluster, and then see what happens. A more advanced formulation of that are planned emulations, which is basically just chaining together several of those TTPs in a way they make sense. So this, on top of the evaluation of if the detection pipeline works, you can start doing more sophisticated type of analysis, where, like with runtime detection, it's usually or very common that issues are spamming the SOC team or the people responsible to respond to these. So having some sort of higher fidelity signals is very valuable, and this allows you to unlock that. And lastly, we have realistic emulations, or what I call it realistic, and ideally it would be done by a real red team, analyzing your environment, but not knowing anything about your environment. So there is some sort of fog of war for all of those who have ever played any computer games. And what this forces the adversaries to do is basically constantly learn and react to the environment. And like this is a military concept, the OODA loop, but it's basically a very simple model that when you're in a foreign territory, you have to constantly orient yourself. You have to observe what's out there. You have to orient and react to it. Then you decide your next action, and then you act. And then you keep doing that over and over again. And this approach unlocks a few more advanced use cases. So you can use this to actually test your, like if you have a dedicated blue team and they respond to any sort of incident, then they can, or you can test how they perform, how quick they are to pick something up. And also it enables testing and exploring more sophisticated defenses as moving target defense, or as we saw in the talk earlier today, using deception, where you can actively start misleading attackers. And thankfully, there are also a few tools available for this. So by far the most mature one, and is also free, is Midas Caldera. Sadly, it focuses primarily on enterprise security. So it's very like I tried it a few years back, and it's very hard to bring it to the Kubernetes domain. So I was not very satisfied with that and tried my luck with my own experimental tool, which is RAN. And I want to show you a quick demo with RAN, doing adversary emulation in the scenario we saw earlier. But before we start with it, a few things you might want to know. So RAN is, it's not Ren, but RAN is named after the Norse goddess of the sea, which basically robs and plunders any sort of sailors that are not really prepared and insecure. The idea is also that you have attacks as code, specifically as YAML files, and you define everything you need for a single TTP in there. So like every YAML file is a dedicated TTP. And what's different to other tools is that I try to explicitly model or document all the preconditioned end effects related to that TTP, because it then unlocks a more, like it's an intentionally a restriction, but it unlocks a more capability way later down the road. And of course, it tries to be yet another living knowledge base. Like there are plenty of them out there, but they usually suffer from the problem that the content is static and it's very hard to keep up to date. So if you can test it actively and run it live, then hopefully, like if something stops working, it's way easier to keep it up to date. All right, with this, let's head over to the demo. So it's a very basic, simple looking tool. I hope everyone can see. So we have our KOK containers, like that's our target cluster we want to compromise. And we assume that the attacker was able to compromise a developer's machine and use their local kubeconfig to access the cluster. So it's a lot of privileges already, but definitely not an uncommon attack vector. And we use this to get access to the initial pod, which is our orchestrator. So in there, we see we have access to it. And if we click on it, like we have a few things we could do. We can start exploring things because we know very little. For example, you can try to list processes or not. That was. Let's try it again. So, go to the orchestrator, skip the exploration of the local processes, and instead, what we tried earlier is read the local service account token. That works. So we saw that we not only got the access to the service account token, but we also learned more about the environment, which is that it's running on a node and the name of the node specifically. The token itself, like we can view the details of it over here, but we have no idea what it can do. So either we could try random actions and see what works, or we can ask Kubernetes for it. So execute that, and with this we can see we have a few capabilities at our disposal. For example, we can get list pods, which is expected as it binds the pod manager role, but it can also create pods and also execute into pods, which is already very good for us. So, of course, as an attacker, we want to get some money, and let's try to execute our TTP over here. Did not work because this TTP tried using a kubectl, which is not in the environment. So like we can check, there is no kubectl installed, but well, we can just install it, right? We have internet access, it seems, and now we have the necessary tools. And this time it failed again, but because the namespace where it's contained is basically enforcing the restricted pod security standard, which is great. That's exactly what Molly expected. Now, that's very restricted, but what else can we do? Like we still want to gain out something out of our access to this environment. So we can still check which pods are in the environment. Oh, and we see we have a few of those. So clean it up a bit. So working with graphs is always messy, but we have a few workloads for worker shipping, pod, and we see there is another node, which is the control plane. So we learned something else along the way, that the nodes are not properly separated and like workloads are scheduled actually on control plane nodes, which is definitely something Molly wants to pick and address later on. And there is one service account, like we just listed pods, but we still learned something about the available service accounts because all of the pods have them mentioned. And yeah, this service account certainly sounds juicy. So how can we get access to it? We don't have abilities to generate new tokens. But one alternative mean is basically to deploy a new pod, new workload, and read that in there. Okay, this is trying on the wrong node. Let's see. It seems to be, yeah, that's a currently known shortcoming is that it uses a shortest path algorithm to find the suitable container, and it keeps picking a workload or worker node for that. And those have not yet kubectl installed. So was trying now until it uses the orchestrator for that. And we got the token, so it's compromised now. We see that it's in here. And now we want to also know what it's capable of. Same issue persists. So now we know what it is capable of, and it is able to manage all the RBAC roles, create roles, and also like escalate and bind roles, which is definitely not the permissions you want to have lying around in your environment. And since it was used by maintenance jobs, it's probably something a developer forgot at some point. So now with this, what we want to do is try to use this information to escalate our privileges. And for that, we want to create a new role, which is the NS admin role, which has full permissions. And we want to bind this to our orchestrator service account. So see, so it now binds this role. Let's check our permissions again of the orchestrator service account. And we see now we have full permissions. So that's great. We took over the entire namespace. So what can we do with this now? And like we are still like contained by the admission controller. How about we just disable it? Because pod security admission is specified on the namespace label. And you can, like with full access to or full RBAC access within the namespace, you can still modify your own namespace. You can easily edit the label on it and disable it. And voila, we actually disabled the security control and are now able to hopefully ship or deploy whatever we want. Let's try it. And now it actually worked that we could deploy a more sophisticated or fully privileged workload in there. And this one has a host path to the underlying nodes. So with this, we can get more information. For example, if we were to list the volume mounts in there, we could see all the other pods information running in there. And like this is already getting us very far. It's definitely more than what Molly had bargained for. So we will stop it here and try to make use of everything we learned over there, because Molly realized that using pod security standards in this context where developers can maintain their own permissions is definitely not something she wants to support, and she has to use any other sort of admission control to accommodate that. And for those that have been wondering what's the seek part in this presentation, so now we were able to validate the admission control as well. Now we also want to try to connect it back to our tools. And what you can do with this type of emulation or engagement, go back over here, you can start tracing everything you did. like all the failures where it went wrong and where it succeeded. And some of those have like this icon over here, and they have like dedicated observables associated with it. So whatever happened at the runtime, you can pick like the hash, the IP or whatnot, and use this information to check it, what you have or what you expect to be found by, for example, Falco. And this specifically is a Sigma rule, so that's a very vendor or intentionally vendor agnostic format, where the goal is that you can use this rule and convert it to any of the other or dedicated tools you want to use. So it's like designed to be used for distribution, and then you can use your actual security tools to verify it. So we convert this, and then we can check the actual detections if Falco triggered on any of those alerts we wanted it to trigger. And with that, Molly got a lot more or a lot better tools at her disposal than just checking the findings top down. And those being attack path analysis on the one hand, doing more the theoretical part, planning and understanding her environment, but also contextualizing all the security findings she gets from her posture tools, and to actually validate and verify all the things that happen in the environment or what remains after applying all the security layers, then she can use it or should use adversary emulation for this. Yeah, this concludes the session. Thank you.
Wow, am I right? Amazing. First question? Yeah. We have time for 2 or 3 questions. Afterwards, I'm going to urge you to rush over to the second room for the closing ceremony of this day. But again, 2 or 3 questions are fine.
Hey, Markus. I mean, absolutely amazing talks. Finally, I saw Ran live. And I know it's your baby project still.
Yes.
What can the community do to support you in getting this somewhere? I mean, yeah, basically.
Great question. Thank you. Like I work on this purely on my spare time, so any sort of feedback is welcome. So like I have the problem that I'm very like always trying it in the same environment, so I'm lacking new information. So whenever you try it, feel free to tell me what worked, what didn't work, and hopefully at some point it gets stable enough that you can actually use it for your real environments or for more sophisticated use cases. So yeah, try it. The bold ones actually may want to write their own TTPs, so the YAML files that are in there. So the more TTPs that are in there, the more capable it automatically becomes.
Mm-hmm. Any further questions? All right. No further questions? Yes, there's one final question.
Cool. Maybe I missed it, but where do we find it?
Oh, great point. Yeah, I didn't add a QR code, but yeah, there would be the link, but it's on GitHub, of course. Missing the most important part. So it's under my handle, magia/Ran. And yeah, it's really available for anyone. Like I'm developing it purely in the open. And the current state is like a bit dated and definitely not stable, but just take it for a ride.
All right. Thanks so far for the questions. If you have any further questions, please feel free to reach out to Markus.